revolution of the earth, summer and winter solstice, and equinox. Now I told you in the video where I explain what are the type of motions of earth, that revolution of earth is what? It is the movement of the earth. So in this particular video, if you notice, this is basically earth, the white one. The line going across is the axis of the earth, right? The movement of the earth around the sun is what is known as revolution. So it starts from this direction, it goes up to here, it then moves from here to here, it then moves from here to here, it then moves from here to here. Sun is here. The rays of the sun goes in all the direction. These yellow ones are the ones which are representing the rays of the sun, right? So what happens is that the position of the earth on different dates is different, right? So what I have done in here is that on June 21 I have taken this position, September here, December here, March 31 here. This one complete revolution by the earth is actually done in a period of 365 days and 6 hours, right? Now we tend to ignore this 6 hours and we consider this 365 days, and therefore we say that 1 year has 365 days, right? And then this 1 year is based on basically the period taken by earth to revolve around the sun. And every year we keep on adding these 6 hours. So 6 hours in year 1, 6 hours in year 2, 6 hours in year 3, 6 hours in year 4. How much do we get? We get 24 hours. Do you know what a leap year is? I'm sure you must be. So in a leap year what we have is that instead of 365 days we have 365 plus 1 is equal to 366 days. And which is the month in which there are more number of days in a leap year? It's February. Normally we have 28 days, but we consider 29 days in February in a leap year. Why does that happen? That happens because of this. So what happens is every year we keep on adding these 6 hours. Once we reach the 4th year, we have 24 hours and we add 1 day to make it 366 days. Right? So this is around those time which is taken to complete. But let me come back to the topic again. Now usually we say that there are 4 seasons in a year: winter, summers, spring, and autumn, right? Do you know why these happen? These happen because the position of the earth changes. Let me show that to you. Now if you see, when earth is here on June 21, what is happening? The rays of the sun will come and fall on this half, right? So this half is going to have what? It is going to have more heat, right? Vis-a-vis the one which is on the back side of this. We discussed about the rotation part as well, right? So what is going to happen is that it is going to be summers in this part, which is the northern hemisphere, right? So what happens is these sun rays fall directly on the Tropic of Cancer. I think let me explain this to you a bit more in detail. So let's say this is the earth and I'm talking about the position on June the 21st, right? This is something which we have depicted over here, but let me just explain this independently to you. So let's say this is the earth, this is the sun. So this is how the axis of the earth look like. So these sun rays basically fall like this. These are basically your Tropic of Cancer. This is your Arctic Circle, right? So when the sun rays fall directly, there is going to be heat over this particular portion where the sun rays are falling directly, right? So you have summers in this particular portion, right? Because the sun rays fall directly on the Tropic of Cancer, there are summer in this region. If I talk about the places which are close to the North Pole, right over here, because this is a little bit inclined towards the sun, what will happen is that these rays are going to fall directly over here. So what happens as a result is that this portion, which is the red one, is going to have continuous day. And this, it might be interesting for you to know that this continuously happens for 6 months. Right? On June the 21st, what happens is that this is basically the longest day. And if it's the longest day, what does follow? And the shortest night. Right? And this position of Earth is known as the summer solstice. Now tell me something. We spoke about the northern hemisphere, right? What will happen in the southern hemisphere? Okay, when I say southern hemisphere, I'm talking about this portion. The conditions are obviously going to be opposite. And why would that be? This portion will not be receiving any light, no light from the sun rays, right? So therefore it will be winters in these places, right? The nights are going to be longer nights, right? Okay, now come back to the main thing. As time passes by, the Earth moves on. Please note one thing, which is that the axis is always inclined in the same direction. Now what will happen is that this portion that we had actually covered over here, is effectively coming like this. So the sun rays are starting to going to fall on the other side to some extent. If we move even further, this green portion here would effectively now stop receiving light, which will now directly fall upon the southern hemisphere. This green part is the northern hemisphere, right? So now the direct rays are falling on the southern hemisphere, and therefore the conditions which were there here for the northern hemisphere will become the condition for the southern hemisphere, right? Why? Because the south pole in this case, which is this thing, is facing towards the sun. This position is known as the winter solstice, right? So these two we've seen. What happens in these two? In these two situations, what is going to happen is that the sun rays that we are talking about basically fall directly on the equator. And this position is known as the equinox. Here, basically the rays fall directly on equator. Here we said it is on Tropic of Cancer, right? Here it is Tropic of Capricorn. Here it falls directly on the equator, and these positions are known as the equinox. And can you tell me what will happen in this case insofar as day and night are concerned? So we knew that the days are longer in the northern hemisphere here, days are longer in the southern hemisphere over here. In these two situations, which is the September 23 and March 21, days and night are equal, almost equal. Days plus nights are almost equal across the earth. So it's not that they are more in the northern hemisphere and less in the southern hemisphere, or vice versa. It's almost equal on the entire earth, right? I hope you would have understood this. Thank you for being with us today.